Hello, everyone. So I wanted to um, discuss question number 126 from Openstax University Physics. I think it's chapter 6, question 126. Two blocks are stacked as shown below and rest on frictionless surface. There is friction between the two blocks. Coefficient of friction would be mu. An external force is applied to the block at an angle theta with the horizontal. What is the maximum force that can be applied for the two blocks to move together? Okay, so what we know here that there is no friction here between the two between the surface of the ground and M2. Uh, Most of the time, guys, when there are two objects together and you want to find out, for example, acceleration. Let's see. Zoom tells me I didn't share my screen. Let's see. There we go. Just in case, I'm going to read the question one more time. Um, for some reason, Zoom told me that my screen was not sharing. I don't know what was happening. Anyways, in case it was having two, it was not recording and it was not showing. There is object M1. There is object M2. There is no friction between M2 and the surface of the table or the ground, whatever surface that M2 resides on, and there is friction between M1 and M2. The question doesn't specify whether that mu is mu s or mu k, but we're gonna figure it out. Um, okay, most of the time, guys, whenever there is two objects in most problems, when there are two objects, and the problem is asking for the acceleration, for example, acceleration of the system, you would go for free body diagram of the whole system, and you ignore the internal forces. Let's see if it's gonna help us for this problem, if that strategy is gonna help us. So if I were to draw the FBD of uh, M1 plus M2, I would draw a box representing the two. There is no friction between the surface and M2. And if M1 and M2, they apply any forces on each other, that's going to be internal force. And I'm not going to consider it in the free body diagram of M1 plus M2. Because in free body diagram of any object, I only consider the forces that are external to it, external to the system. What are the forces? It's going to be normal force. There is going to be um, weight, which this weight is going to be weight of 1 plus weight of 2. And normal force, yeah, it's the total normal force on the object, on the two objects on the system. And there is a force of F that is applied at an angle of theta. And as I said, there is no friction. So that's it. That's the free body diagram of the whole system. The question is, if I were to write down sigma F equals to m total times A, the acceleration of the system, that's going to give me two equations. Sigma Fx is going to be m total Ax, and sigma Fy is going to give me m total Ay. I know Ay is 0. They're not going to go, these two objects, they're not going to accelerate up or down. I forgot, sorry, my bad, my apologies. I had to draw X and Y axes without drawing X and Y axes, writing down sigma Fx and sigma Fy. It's meaningless. You have to show the coordinate system. I should have shown it first, right after the free body diagram. Anyways, that's the coordinate system. I know that sigma Fy is going to be equal to 0 because acceleration on Y is going to be equal to 0. The system is not gonna, these two objects, they're not gonna accelerate up or down. But acceleration on the x can be non-zero. These two objects, they can move together with constant velocity if possible. We're gonna see if that's possible, or they're gonna have an acceleration. Okay, no. On the x-axis, the only force is F cos theta is going to be equal to m total, which is going to be m1 plus m2 times acceleration. Okay, and no, I don't have anything right now to find out for acceleration. Um, F is going to be equal to m1 plus m2 divided by acceleration. I don't know the acceleration. There is no way that by drawing free body diagram of the whole system, I can find out the acceleration. Okay, now the other thing that this tells me, is acceleration cannot be zero. It's impossible for acceleration to be zero. That's guys is very important and it's easy to be overlooked. Um, Acceleration cannot be zero here. Why? Because there is a net force on the x-axis on the system. If there is net force, there's going to be acceleration. It's impossible to have zero acceleration if there is net force. So there is a net force on the system. So it's it's impossible that the system is going to move together with constant velocity with these forces applied on it. Okay, now what are we going to do next? We're going to take a look at the free body diagram of each of them individually. Okay, so I'm going to draw the free body diagram of each of them individually. I'm going to draw the free body diagram of M1. On M1, there is F. This is angle theta, and for all of them, I'm going to consider X to be to the right, positive Y to be upward. There is going to be normal force on M1. There is going to be friction. Friction if F, the X component of F is trying to move M1 in this direction. The friction is always opposite in the direction of a sliding of the two objects. So friction between M1 and M2 is going to oppose it. Therefore, friction is going to be in this direction. Friction is going to be in this direction. Okay. So the thing is this going to be a static friction or kinetic friction? I will tell you in a bit. We have to label this with either static friction or kinetic friction. What are other forces on M1? This is FBD on FBD of M1. Okay, what are the other forces on it? That's it. That's it. There is no other force. Now, what should we do with that F? Is this going to be Fs? This one is going to be Fs or Fk. If it's going to be Fk, that means the two objects, they slide against each other. They slide with respect to each other. The question is asking, find out F so that they move together. They don't have a relative motion with respect to each other. They don't move with respect to each other. They move together. As a whole, they move together. So that forces you to use Fs. That forces you, that condition forces you to use a static friction for M1. Now, let's write down Newton's second law for M1. Sigma F on M1 is going to be equal to M1A. On the x-axis, sigma Fx is going to be equal to MAX. AX cannot be zero if you want them to move together. And sigma Fy is going to be equal to MAY. Okay. There is another reason that A cannot be zero. It's because of this. There is, if you look at the free body diagram of the whole system, there is going to be a net force on the x-axis. You will see this on the free body diagram of M2 as well. Okay, so on the x-axis, I have F cos theta minus Fs equals to M1 times A. And on the y-axis, I have, sorry, I forgot the M1G. And on the y-axis, I have N1 minus M1G minus F sine theta, the y component of F. This is going to be Fy, which is going to be F sine theta, and this is going to be Fx, F cos theta. Okay, and this N1 is going to be equal to M1G plus F sine theta. We're going to need it because on this side, F cos theta minus Fs is what most of the time, because when you have friction, because friction is going to be equal to mu times normal force, whether it is static or kinetic friction, you need to find out normal force. Most problems. Multiplied by N1 equals to M1A. Okay, that's going to give you F cos theta minus mu s. I'm going to plug in N1 here. The first term is going to be mu s times M1G. The second term is going to be, the minus is here, minus mu s times F sine theta equals to M1A, right? So what I did, I plugged in this N1 into here, term by term. Okay, guys, no, A cannot be zero. A cannot be zero. That's the key. Again, I need to find out A. Just same issue that I got there. No, I developed the problem more. No, I have the free body diagram of M1. No, I can take a look at the free body diagram of M2 to see if I can get any information regarding acceleration. No, FBD of M2. On M2, what are the forces? There is going to be M2G, of course. There is going to be normal force, N2. There is going to be, if you look, because this N1 comes from where? M1 has a normal force. That M1 resides on M2. M2 provides the surface, and M2 applies that N1. Therefore, based on Newton third law of motion, there is going to be a reaction N1 prime on M2. And this N1 prime as a vector is going to be negative of N1. And their magnitudes, of course, are going to be the same. Okay, that's for the y-axis. What do we have on the x-axis? On the x-axis, there is Fs. M2 applies two forces on M1. One is going to be the normal force, and the other one is going to be the static friction. N1 prime was the reaction of N1, and now I will write down Fs prime. Fs prime, this one, and these two guys, they are action reaction forces. And you can say Fs prime as a vector is going to be equal to negative of Fs. They are action reaction forces. And in terms of magnitude, they are going to be exactly the same. Okay. Okay. Now, Let's write down, guys, on the y-axis, what I want on the y-axis for M2. Um, there are forces N2 upward, M2G downward, and N1 prime downward. N1 prime is going to be equal to M1G. But the thing is, I don't need them. I don't need them. What I want to extract from the free body diagram on M2 is acceleration of it. On the x-axis, the only force acting on it is Fs prime. Fs prime is going to be equal to M1 times A. That's it. That's it. And this Fs prime is exactly the magnitude of it is going to be exactly um, magnitude of Fs. The magnitude of this and the magnitude of Fs are exactly the same. Um, so uh, you can uh, we can place it there. We can place this Fs prime into the equation for the equation that we got for. Let me highlight it with green. Um, this equation for M1 and find out an expression for F. So guys, I made a mistake here. That has to be, so this has to be M2. This has to be M2A. So this is magnitude of Fs prime. Guys, I'm dealing with magnitudes and it is positive Fs prime. And I want the magnitude of Fs prime and magnitude of Fs are the same. So M2A. No, I have an expression for A. A is going to be equal to Fs divided by M2. And I can put that into either, it's up to you whether you're going to be more comfortable putting this into here or putting it into here after you plug in the values plug in the expression for N1. Let me do one of them and follow that. But that's it. That's the procedure. Either of them are going to work out. Um, so let me label how many equations we used. This was equation 1, this was equation 2, this was equation 3, and we didn't need to write down equation for the Newton's second law of motion on the y-axis for M2. Okay, so what I'm gonna do, let me put acceleration into there and then plug in the expression. So I'm going to put this acceleration. I'm going to put this acceleration into equation 1. That's going to give me F cos theta minus Fs is going to be equal to M1 multiplied by Fs divided by M2. Okay. So I put it into here. I haven't done this. Let's do this later on. Um, why do I say later on? I decided to do it later on because there is Fs in A. A has Fs in it, and I want to. I'm more of a lazy person with calculations. I want to replace Fs is going to be equal to mu s times n1. I want to replace n1 this expression at the very end. Excuse me. Or you can do it. You can do it here if you want it. Okay, so that's going to give me F cos theta minus Fs, or let's do it this way. F cos theta is going to be equal to Fs plus M1 multiplied by Fs divided by M2. So this is going to give me F cos theta equals to Fs. I'm going to factor it out. 1 plus m1 divided by m2. F cos theta is going to be equal to, no, Fs is mu s times normal force times n1. Mu s times m1g plus F sine theta. That's going to be Fs 1 plus m1 m2. Now, what I want, I need to rearrange this whole thing in terms of F. So I will do it this F here and there is F here. Let's rearrange them. So I would get F cos theta minus, this term is, if it comes to the other side, minus F sine theta multiplied by 1 plus m1. There's mu s here as well. This mu s has to be multiplied. M1 divided by M2, yeah, equals to mu s M1 G multiplied by 1 plus M1 divided by M2. Okay, what I would do, I would factor out F. I would factor out the F here. That's going to give me F multiplied by cos theta minus mu s sine theta multiplied by 1 plus m1 divided by m2 equal to mu s m1g multiplied by 1 plus m1 divided by m2. And then F would be equal to mu s m1g 1 plus m1 over m2 divided by cos theta minus mu s sine theta 1 plus m1 divided by m2. That's, if you wanted, you can simplify it even further. I don't know if you want, you can multiply this cos theta by, this is term by term, but it's not necessary. I hope I didn't make any mistake. Let me, in the algebraic expressions, let me take a look. Let's start from the beginning. F cos theta minus Fs, is going to be equal to mass times acceleration, mass of m1, this top one times acceleration. On the m2, I only have friction, static friction in the direction of motion equals to m2a, and a is going to be equal to Fs divided by m2. If you replace a by Fs divided by m2, you're going to get, that's basically, this is the replacement on equation 1. And let me make sure n1, I got n1 right. n1 minus m1g minus f sine theta is going to be equal to 0. Yes, n1 is right. And then g plus, then I put fs to this side, factor out fs, 1 plus m1 divided by m2. Then instead of fs, I wrote mu s times m1g plus f sine theta. Then I rearrange it for f. Seems like there's no mistake. If there is any mistake, you found any mistake, please let me know. But yeah, just this is it. The question wants only algebraic expression for it. If values are given, you can add up the next step to this problem. If values are given, m1 and m2, you plug in the values and for theta and mu. Anyways, my main point here is, guys, this is the acceleration, so that these two systems, how are they going to move? Let's look at the big picture. How are they going to move? This is the bottom one, this is the top one, this is the force acting on it. These two are going to move together, with the acceleration, with the same acceleration. It's impossible for acceleration to be equal to zero. Why? Because if you look at the whole system, guys, there is going to be a net force on the y there is no net force on the y-axis, but there is a net force F cos theta on the x-axis. And if there is a net force on any axis, there is an acceleration on that axis. So acceleration cannot be zero. Okay. This is it.